array. Okay, so what exactly we are given here is that they are saying they have this array which is sorted. Okay, so this is what they are saying. So what exactly we have this array uh, this one. This is the sorted array 0 1 2 3 4 5 6, and they rotated that one at some point and that one became this one. Okay, so if you can see this, so this 0 is shifted here, 0 1 2, and then the remaining part goes on to the left side part. Right. Okay, so to solve this one, you may be aware of binary search, how to use the binary search, but this is something advanced. We can say that it's a variation of the binary search only. Okay, to solve this one, it's not that tough, it's an easy question, but just a slightly we have to modify the binary search, and we will see how we can do that. Okay, so now they are saying let's write it down. Let's say we have this 4 and 5 6 7 0 1 and 2, and they have also mentioned that this is 0 index. Okay, so let's say this is my 0 index, so 0 1 2 3 4 5 and 6. Okay, now if you see this, if you observe this, at this point they rotated this array. Okay, so now we can say that this is my right part which is sorted. Okay, so right sorted, and this is my left part. I can say like this, right? So this is my left sorted part. Okay, so again, let's say I have a target is, let's say I want to search for 0, right? So they are saying what exactly they are looking for. So they are saying given the array nums after the possible rotation and an integer target, return the index of the target. Okay, so let's say if this is my answer 0, then it should return 4, right? So basically we have to find this one into this rotated sorted array. Okay, now as I told you, this is the right sorted and the left sorted part, so let's use that one and try to solve this one. Okay, so we can say that there are two cases. One is for the left sorted part, another for the right sorted part. Okay, so let's think of that, let's go for the left sorted. Okay, I'm calling it ls means left sorted. So in that case, if I'm looking my answer into this one, okay, so how exactly we're going to say that, right? So let's say one more thing I just want to tell you before going with that, right, which is the mid pointer, because in the binary search we always get the middle, and then we see if my target is less than mid, then I'm going to search here, and if my target is greater than mid, then I'm going to search here, right? So to find that, we will take the first pointer, left pointer and right pointer, and then divide it by 2. So this is my mid. Okay, now let's try to do our searching in the left hand side. Okay, so this is my first case, this is my case 1, I'm going to say. Okay, so when we can say that this is the left sorted, right? So the thing is that here, so the thing is that if I can say, if my value at L, let's say this is my L and this is my R. Okay, so I can say, and let's say this is my mid pointer. Okay, this is my mid. So I can say if my L is, so whatever the value at L is less than or equal to the value at mid. Okay, so in that case, if that is the case, then I can say that this is left sorted, right? If it is left sorted, then I can have two conditions here, because if normally if it is not rotated, so in that case I will directly look into this and check if my target is less than mid, then I will check here. If it is not, then I'm going to check into the right hand side. Okay, but in this case I need to have the two conditions here, which is, let's say my target falls into this range. If my target is falling into this range, which is left and right, okay, I'm going to say like this, So this one, if my left is less than right, or this mid, if my left is less than mid, so this is my left sorted part, right? So this is my left sorted part, and I want to check my target falls here or not. Okay, let's say my target, if my target is greater than or equal to the value at left, right, and I want to say if my target is less than the value at mid, right? If that is the case, then I have to search here. My right pointer should be shifted here, right? So in that case, I'm going to say my right equals to mid minus 1, right? This is the first case. Else, I'm going to do something like that. Else, if my target is not falling, if it is left sorted, and if my target is not here because it is rotated, so it could be here, right? In that case, I have to look into the right part, which is plus 1. Okay, similarly, this is my first case, right? Now let's go for the second case. Second case will be right sorted, so let's call it right sorted, right? So now in this case, when I can say that my array is a right sorted array, right? So when whatever the value at mid, okay, is less than or equal to whatever the value at right, right? So if you can say this, so the value at, let's say this is my mid, it is 0, right? 0 is less than right, so I can say that this is the sorted, right sorted, right? So here in this case, I'm going to again check for if my target falls between this, if my target, or let's call it T only, if my target, which is T, okay? So let's say if my target is greater than the value at mid, and I'm going to say this, if my target is less than or equal to R, right? So if somehow my target falls between this range, right, then I can say that I have to shift my left pointer to mid plus 1, right? Because target falls into this part and I am here, so then I have to move to this one, right? Because my target lies in the right hand side, so in that case I have to move my I have to move the left pointer to right side, right? Else what exactly I'm going to do? Else I'm going to simply, if it is not there, let's say I'm searching for 7, okay, and this is the right sorted, but as it is rotated, my 7 will fall on the left hand side, right? So in that case, I'm going to update my right pointer to mid minus 1. Okay, now what will be the third case? Third case or the first case we can say, but let's call it third case. Third case will be when we will find our target, right? Let's say if my mid is equals to target, then what exactly I'm going to do here? I'm going to just return my index, which is m in this case, right? And this will be the answer. Okay, now let's code this one. Okay, so let's try to code this one. Now what exactly we're going to do? I already solved this one, so that's why you can say like I already solved this one with 100%. Okay, so let's see. I'll show you like what exactly how we can do that, right? So here let's take the L as pointing to 0 index, and then my right pointer is pointing to at nums dot length minus 1, which is at the end, right? Okay, now to think of this one, you can say like this, my let's say this is my array, right, and my left is pointing to this element and my right is pointing to this one. Okay, and somehow if we get the middle element, my mid will be here. Okay, this is how I'm going to find it. Okay, and this part is this part up to this is the left sorted, and up to this is the right sorted, right? So now let's try to solve this one. Let's say my L. Okay, so as I'm incrementing my L, that should not go beyond this. So L should always be less than nums dot length, and I'm reducing my R right up to here, so that should be greater than, so R should always be greater than or equal to 0. And one more thing here is that when I'm incrementing L and when incrementing R, so they will cross each other at some point, right? If that is crossing, then that is an invalid case. So my L should always be greater than or equal to R, right? Now let's try to solve this one. Now let's take the middle element. Let's say I'm calling it as M. M will be equal to L plus R by 2. Okay, now once we have that middle element, we will see like if it is matching with the target. Okay, so I'm going to say if my nums of M equals to target, right? If it is matching, then this is my answer. I'm going to return M. This is the index. Okay, if it is not matched, then I'm going to, like as I told you, we will look into the left side and then right side. So let's call it left sorted. So RTD sorted. Okay, so for this one, when I can say my array is left sorted, so I can say that when my element at the left part at the index L is less than or equal to element at the mid, right? Then I can say that is a left sorted. Okay, if it is left sorted, then I'm going to check my target. If target is greater than nums of L. Okay, if my target is greater than or equal to nums of L and my target is less than nums of mid, right? So if it is greater than nums of L and then it is less than mid, less than mid means something like this. This is my L and this is my M, and if my target is something I'm searching for phi, if it is falling in this one, okay, in this range, so in that case my R pointer should be here, right? So R should be M minus 1, and else if it is not there, then I can simply say my L should be equals to M plus 1, because if my target is not here, then as this is rotated, so obviously it will be at this part. So just I have to increment that left sorted. Now let's have a condition for the right sorted. So when I can say that this is right sorted, okay, let's say sorted. Okay, so I can say this is right sorted only when the element at M, nums of M is less than, right? Let's say my M is at 0 and 0 is less than equal to element at R, right? So then I can say that this is the right sorted part, right? So in that case I can say this is right sorted. Okay, now let's copy this one and let's try to add it here. Okay, now I can say when my target falls into this, okay, when my target is greater than or equal to M, means what I'm saying, like if my target is greater than M, not greater than or equal to, but this is greater than M and less than or equal to element at R, right? So my target, like it is greater than or less than R, right? So if it is greater than and then less than or equal to R, okay, if that is the case, then in that case I'm going to increment my L pointer. L will equals to M plus 1. Okay, if my target is falling here, then I will start searching at this part only. So in that case I'm going to increment my left pointer to move to right. Okay, if that is not the case, then I have to move to the left side. Basically means if this part is sorted and then I'm searching for, let's say I'm searching for phi. Okay, so in that case 0 1 2 and then 5 will fall at this part. We cannot search it here, right? Because that is rotated. Then in that case I'm going to get my right pointer and moving it to the left side so that I can search at this part. Okay, once we have that, when my target is matching with number at M, then I can return M. else I'm going to return if, as it says, like if it is not matching, we can return -1. Return -1. Okay. Now let's try to run some result first. One thing, let me check. I think I missed something. Missing return statement. Okay. Why it's not going down? One minute. So where I kept that, I think I added this return statement in the while loop. So that should be outside of while. Yes. Okay. So this my while is closing at this one, and then after that I'm going to have my return statement. Okay. Now let's try to run again. Why it's saying false? Something I missed somewhere. -1. What exactly we have done wrong? If my nums of L is less than or equal to nums of mid, which is fine, so this is left sorted, and then I'm saying if my target is greater than or equal to nums of L and less than M, so in that case, if at this point my target is between this range, then I have to get my right pointer here and then left pointer here. If my nums of M is less than or equal to nums of R, which is right sorted, okay, which is correct again, so then my target should be greater than nums of M and target should be less than nums of R, which is fine. And in that case I'm going to incrementing M +1 and then plus right, which is correct only. This is also correct. And what exactly I'm missing? Something. L is should be greater than or equal to R. No, sorry, L should be less than or length. R should be greater than or equal to 0, which is correct. And L should always be less than or equal to less than or L should be it is wrong. It should be less than or equal to L should always be less than or equal to R. Yes. Now let's submit. Right, so this was the mistake I did. So because L should always be less than or equal to R. If we submit this one, and voila, it's 100%. Okay, so this is how we can do it. And one more thing, as you all know, like my research uses login time, so we solve this question in the login time only. Okay, and in terms of space complexity, like we are not using any extra space, so that space complexity will be 0 only. Okay, and in terms of time complexity, is taking login time, as we are dividing this array into half every time we are solving this one, right? Okay, then yeah. Okay, thanks for watching, guys. Hope you hope you learned something here, or you understand the logic behind it. Okay, thanks. Let's see you in the next video.